This will only last a minute, so just bear with me, and it'll be worth the wait, I promise. I'll talk through it. So this morning when I woke up, I had some leftover fried okra and some fish. And there's a few French fries out there, I think. And I was going to take them all. Chickens. They were sitting outside in the cold. Anyways, I took them. I let the chickens out and dumped that stuff out. Put a bunch of feed. I have like my grain behind mix, pellets, like 3 or 4 different types of grain mixes. So I just like to give them everybody peanuts and stuff. It's really nice blend. They don't even need that protein, but they got to compete with all the animals, and so. I overfeed them. But I gave them way so much food this morning with that okra and that fish too. I put it out and I put it in there. They've got like this feeder thing, and sometimes I'll dump some of the grain out, but this time I didn't. I just put it on the left side, and on the right side I put the food. And I went back, let them out. It's about an hour later. I warmed my coffee up in the microwave, and when I opened the microwave, there was a plate of turkey and dressing. It's been in there since Thanksgiving. I was like, oh shit, I thought I ate that. Anyways, so I grabbed that and ran out there and to go put it in their thing, and their feed bowl, it's been not even an hour. Their daggum feed bowl was completely empty, licked clean. And it's them damn deer. It is. It's the deer. They eat everything. They just eat it all. Like, there'll be 6 of them sitting there eating out of their little bowl that I've got. And my dog runs them off. My dog will chase them off every time he sees them, and they'll just come right back. Like, he runs them to the edge of the property, and then when he comes back, they just basically they'll be back within a minute. Ooh, it's annoying. Anyways, I took that turkey and dressing out there and put that out there, and then about 15 minutes later, I was looking at them deer come over there. And I told my dog, I said, them deer out there. And they run off. But you know what? They ate the turkey. They didn't eat the dressing. They ate the turkey. I couldn't believe it. I was like, those rascals. Thanks for the protein, jerks. Anyways, I thought I'd make a longer video. I embarrass myself every time I make a video. No matter what, when I listen to myself recorded, I sound gay or arrogant. I don't know how it depends on the perspective you want. And it's just like, that's the last 2 things that I want to sound like, but I just can't help it. It's something about my voice. I'd rather sound more Southern. I am Southern, and I don't mind to talk Southern. I'm proud of my dialect. I love Southern dialect, but when you're talking to other people, it sounds weird, I guess. I don't know. And I don't even sound I don't even sound like a normal Southern person. I sound like a weirdo. I probably am a little feminine. My dad has a really masculine, deep voice. You know, he sings bass in church, and I wish I had a voice like that. Some people have great radio voices, but, you know, not all of us are blessed with that sort of thing. My last video sucked. I'm terrible at communicating this shit. I really am. Like, it's so complicated. It's really not even that complicated. It's really not that complicated. It's a complicated, the concepts aren't normal concepts that you have to discuss. And I'm not educated on this. Like, I'm self-taught. So it's like, I don't really know what I'm talking about. And, but it was better than, the last video I made. Like, I made a video a few months ago. Most of you didn't see it. I only kept it up a few hours. I took it down. And, and it's kind of like I oversell my stuff. I oversell it. I oversell it because it's so theoretically sound. I try to make everything as theoretically sound as possible, but I'm not able to communicate that soundness. And so I could be wrong. I think there's so many crackpots out there. Every time you say anything on the internet, so you have 30 crackpots respond talking about, or people that aren't even crackpots, people that just have a general understanding, and they they write the harshest comments possible. And so, it's very difficult. Yeah, and I kind of suck at math anyways. I mean, I know algebra pretty well, and I'm really passionate about physics. Like, I feel like I understand physics really well. Not all physics is understandable. But anyways, I'm rambling. What was I getting at? Like, my method, I think that's kind of the approach of this video, is to just kind of give people the ability to research for themselves. Because, like, this stuff, I think there's a little bit of subjectivity to it. And what I mean by that is that physics isn't subjective, but understanding it is. You can know equations. Actually, if you know equations, you probably understand it. I mean, that's a good way to understand physics. But you can say stuff all the time, like objects fall at the same rate in a gravitational field. And, there's all kinds of... It's like, that's just not true if you know the equations, I mean, a black hole doesn't fall the same rate as an apple. And it's like, you gotta have these different perspectives, and those come through thinking about it from a fundamental level. And that's what I like to do. Like, it's my hobby. It's like my favorite thing to do is physics. And I don't know. People think that like, I just do it because I want people to think I'm smart, and that sucks because it's not true. That's not. I don't. First of all, I'm not smart. My IQ is like maybe 130. 135, something like that. Like, I'm dumb enough to know that I'm smart enough to know that I'm pretty dumb, and also, I don't have, I have a bachelor's degree, like, I don't know, like, I'm not a PhD. I don't know the standards. There's supposed to be this, I saw a tweet today that PhD, you get a PhD so you can learn the standards of research. And, there are no standards to research. There should be standards to... there's social standards, we have social standards, but other than that, critiquing ideas and selling ideas, like, you kind of don't want to limit that, like you should be able to have an opinion, and you should be able to express it in a bold way. I don't know what the standard means. The standard, if they're talking about rigor, then, physics is it requires rigor. Like, there's not like, I don't, and so some science doesn't require that rigor, and so I get that, and that rigor, we're not always talking about physics here, but I don't know. I think that the academics do well, don't get me wrong, but they have stalled progress. There's academia has pretty well failed for the last, 50 years or so. Progress has kind of stalled. Like, there's been some progress in some areas, don't get me wrong, and some of that's come from academia, but I think that the Ivy League has been taken over. I don't think that it has the credibility that it once had. I could be wrong. I mean, it's just, I'm going off the last 10 years. The last 10 years, it's been absolutely pathetic. But it's not like they have a challenger. I mean, Joe Rogan and people like me. I mean, not people like me. I'm not challenging it. I have 500 fucking subscribers. Anyways, but I mean, the alternate media, the just individuals making stuff, do they challenge academia? Not really. Not really. But the general public has always been the challenge to academia. And if you're talking about the general public is making their own content, then they're doing their own research. And so if you're doing your own research, you need to kind of develop a process. This isn't a standard. I mean, in physics, the standard is the answer. So if you don't know how to do physics, then you're not going to be able to do physics. But the standard in physics is physics. Like, you have equations, like this stuff is pretty rigorous just within itself, because physics is a field that intuition works, but is not the final determining factor. Mainstream physics is, they allow a lot more. They're a lot more lenient than what I would like, but they collect all of these failures and then they call them successes. It's stuff like, just the entire lambda CDM model, like expanding space. First of all, expanding space doesn't even make sense. Like, there is literally no theory for expanding space. It's just the theory is space is expanding. And so that to me is just red flag. Like, why? And yeah, physics doesn't say why, but at least Einstein has the presence of mass curves space-time. And then you have space-time expands. Why? Like, in general relativity, you have the presence of mass curves space-time. And then in lambda cosmology, you just have space-time expands. Why? They don't know. There is no answer to that. So it's not a theory in my eyes. It's not something you can just discredit because, like, they're saying something. They're saying space is expanding, but when you go down that road, it doesn't make sense because it just gets worse. First of all, they start off with the assumptions in the cosmological principle. Homogeneity, like the universe is homogeneous and isotropic. And they really preach these concepts. I mean, they stand by these two, and these are the two most basic things in modern cosmology, and they're both false. From a technical level, like they're not just false philosophically, or I don't even know what I was about to say there. But they're, if you press them, they will agree that they're false. First of all, it's obvious that the universe is not homogeneous. If the universe was homogeneous, we wouldn't exist. It's not homogeneous. You can say near homogeneous if you want, but that doesn't even describe the universe. The universe has a giant collection of objects that range from zero. Well, not zero. There's nothing that weighs 0 kilograms, but the mass of objects ranges from the Planck mass to all of the mass in the observable universe. And so that's an extraordinarily inhomogeneous structure. It's symmetrical, but it's not homogeneous. Mass density is scale dependent, okay? And that right there is 100% the truth. And it's more accurate than the homogeneous model. And so that is why that is one of the things that has compelled me to research, is because mainstream science, all the Neil deGrasse Tysons out there, are following a principle that is 100% false. And so that bothers me. So that's why, to me, it's like there's all these treasures that are hidden. And everybody's like, oh, we've already looked over there. And you're like, no, you didn't. It's not checked off on the list. And everybody's like, oh, he's crazy. He's looking over there. And I'm like, look at all these treasures. Guys, I found all these treasures. And everybody's like, shut up, crackpot. Anyways, I am a crackpot. I don't deny it. I like crackpots, though. Well, not really. Most sometimes the term crackpot has turned into meaning somebody that's annoying. I like crackpots that publish research but don't annoy people. There's two different types of crackpots, I guess. I used to annoy people. I don't do that anymore. I try not to. What else do I have on my list? Dark energy. Yeah, that's another thing that doesn't make sense. Dark matter doesn't make sense. These are not successes. These are not successes. When you ask ChatGPT, let's just ask ChatGPT. Let's just do this. Lambda CDM. Oh, we don't want to do that. I'm recording. I thought it would just read it. Lambda CDM is the model of cosmology, is a robust framework supported by a range of observational evidence, such as the CMB, large-scale structure, and supernova data. See, these are not... Lambda CDM doesn't... This cosmic microwave background radiation is the most convoluted, disgusting theory that's out there. It's uncriticizable. It doesn't even make sense. I hate it. I've read into it so many times looking for holes, and I can't even grasp it. It's so absurd. Anyways, but everything else is failure. Large scale structure, failure. Supernova data, failure. These are failures. These are not these are not evidence. You can't use your failures as evidence. Let's just say this. You can't use failures as evidence. Predictive success, such as massing the anisotropies. See, that's not really a prediction. These aren't really, anyways. I'm not going to debate Lambda CDM. It doesn't. They don't provide any answers, so there's no reason in even challenging it. So let's get on to my workflow. One of the things that I wanted to share with you is math pop-up. See, this is amazing. So this is amazing. If you don't even know math, you can do physics. Now, like most of these, it's not, if you don't know math, you're not going to be able to do physics. This is not true. But if you have a good understanding of algebra, then this is an extremely helpful tool because you don't have to actually do this. I used to have a whiteboard sitting beside me, and I would just write down the equations because it's so much easier to just kind of have an extension of your brain, because your brain can do this pretty quickly. But when there's these weird things like this 1 minus shit, it gets in the way. You know, that stuff gets confusing. And so you can just use this to change the variable and it'll output the answer. I love this tool. I mean, I use this all the time. And I've got this giant book of equations that are nice and organized that I use. And so that sort of thing helps you when you're trying to describe a physical theory that you have in your mind. And you have to be as honest as possible and then use these equations to see where it takes you. I'll tell you something else, ChatGPT, I use it all the time. It's absolutely incredible. Especially, I like the older models, and I like this Wolfram because it can do more precise equations than just what ChatGPT normally uses Python, and it doesn't always. Anyways, Wolfram's really precise, and it's good. The problem now is that they change the models to where you don't know what model you're using. That's what's annoying. It's got the ChatGPT preview, which to me is the worst model there is. I hate it so much. It's just so verbose, and it gives all these bullet points that aren't really necessary, or they don't even have anything to do with the conversation, and so it gets on my nerves. And I like to use the older model. It's not as accurate, and it makes mistakes quite a bit. It really does. You got to pay attention. And the newer model doesn't make those mistakes as much, but the newer model will make a mistake, and then it'll stand by that mistake. Where the older model will if you point out the mistake, it'll be like, oh, okay, I see now. One of the problems though is if you point out a mistake with the older model, then it starts trusting you more than it like takes on the inferior role. And when it does this, it tends to make more mistakes and it'll agree with you on everything. And so I usually want it in the argumentative tone. I want it in the argumentative tone because I'm using it for validation and for confidence. I'm using it for another person. It's kind of like peer review. I'm like, what do you think about this? And so I don't want it to be, my friend. I want it to be my enemy. But the newest model is my enemy so much. Like it mimics a modern academic instead of your, a true peer. Like it's like an academic talking to a child. That's it's like an MIT professor talking to a 12-year-old. And I hate that. That's awful. I mean, I haven't figured out a way to steer it either because it just puts out this giant list of things. Anyways, I think that Wolfram is great. Like I'll just go through this one. This is a question I asked earlier. So like I always try to give it as much information as possible in the beginning. But then you can always refer to the initial question as you're going along if it forgets. So it's what I did is I just ask it to formulate the metric that I've been trying to do, and like I've not found a form that I really like yet. It's just the Schwarzschild metric, and so I may have to tweak I wanted to use general relativity and be really strong, and have a good metric that communicates the idea that's perfect as a solution to the Einstein field equations, and just really have it mapped out. But now I'm starting to rethink that approach. Like I'm kind of want to just start with the Minkowski metric. I kind of do. Anyways, and I know that seems weird, but I think that there may be something else. I don't know. The research is what I love the most. I don't really care about telling it to people, and I'm not even that right. So I need more validation before. And plus, I can't publish. I've submitted numerous articles. They always just reject me immediately. They do. And I try my best. I try to hide everything but I'm not good at writing, so that's part of the problem. So anyways, I tell it what to do. It just repeats itself. Well, did we ever get to a metric? Okay, it's using the K here, which is silly. Okay, yeah, so it said that it's not perfectly flat outside the Schwarzschild radius. And so my response is, see, that was the question. I wanted to formulate the metric and tell me if it's perfectly flat outside of it. And by perfectly flat, I mean zero. Like it reduces to the Minkowski metric. And see, the Schwarzschild metric does reduce the Minkowski metric at an infinite distance, but at the Schwarzschild radius, there's a little bit of curvature there, and that's what it said to me. But that's because the perspective that's like you're looking at the black hole now. When you're describing the black hole with the metric and you define RS is the end of that metric. That's literally the end of that metric. That metric's done there. And so when you say an outside observer, now you're including another metric. Okay, now you're actually talking about another metric. You're not talking about that black hole metric. If you're talking about that black hole metric, you're talking about the observer from the perspective of the black hole. And so that RS is the end. And so I want to show that at the RS, it reduces to the Minkowski metric from the perspective of being inside the black hole. And the reason I want to do that is because I think that the universe it's not a black hole, but it is a coordinate singularity, which is the same thing. We have a Schwarzschild radius. It's not the same thing as in, it's not, a coordinate singularity is acceptable. Physical singularities are not. And the reason we have physical singularities in general relativity is because they're using the concept of zero. And zero is not real because the concept of infinite doesn't exist. I mean, it does exist, but general relativity is like a solution to the infinite, because RS, the Schwarzschild radius, is now the infinite. That's the end. It's a boundary, okay? And the perspective that I'm trying to draw here is that the boundary, every point in the universe is the center of this boundary, or the center of this metric. And the Schwarzschild radius is the boundary. That's the observable limit. And so I asked Wolfram GPT here to formulate this metric, and it says that it's not exactly curved, but it does reduce to that, the weak field limit, whatever, which is the standard answer. And I said, I don't understand why it wouldn't be perfectly flat, though, provided you're never able to leave the perspective. This is why, this is because you can never leave, you can never model outside of this metric. Everywhere you go, you're in the center of this metric. And so he agrees with me. Really great. I feel like when I'm talking to Wolfram ChatGPT, I feel like I'm talking to Stephen directly, which is great. Stephen Wolfram. And so we argue a little more. Okay, it says the problem with that is that there's a relativity of the frame. As an observer within the Schwarzschild radius, the space-time geometry inherently defines their experience. So it's saying there's nothing to compare it to, okay? And so this is a problem. It's saying, since the Schwarzschild solution describes the exterior geometry of a spherical mass, all observers inside this space-time carry the metric with them. To this observer, the metric center coincides with their position, and they naturally perceive the space-time around them as symmetrical and isotropic, inaccessible outside. If every observer is confined to the boundary, they are inherently unable to perceive or test outside regions. Any notion of curvature beyond this radius becomes irrelevant to their experience. For them, the observable universe is self-contained, and they might interpret space-time as locally flat everywhere outside of RS. Okay, then it's got this philosophical consideration. The model you're describing is self-referential in nature. Everywhere is effectively the center due to the symmetry and confinement imposed by the Schwarzschild radius. Thus, from this perspective of general relativity, it could be argued that there's no measurable curvature relative to the observer, since all measurements would yield results consistent with the same metric everywhere. And so this opposition will confuse you. It's confused me several times. I've been hit with this numerous times. And it'll trick you. You'll be like, oh yeah, that sucks. There's nothing, it's like a problem with this. And you're like, okay, what do you do? But if you think about this, okay, this view the opposition to this is that you take all of these objects, like a star and the galaxy or atoms, and you place them in their own metrics. And then you overlay everything together. And so that's what mainstream physics does. Now, that may not be philosophically what everyone claims is going on. Honestly, it's not really defined. But it's what they do when they're modeling a star or the FLRW. The FLRW uses the Minkowski metric, which is the same problem, okay? Anyways, we'll get to that in just a second. When they're using a star, they're modeling multiple stars with their own metrics. But they also claim that it's a continuous manifold. And then they use these arbitrary boundaries like a star or a galaxy or whatever they're describing. And this is the standard approach. And you just imagine it in its own little universe you can add the FLRW on top of that if you want, or whatever other layered metric. But it's what they're doing is still they're imagining this arbitrary object inside a universe of its own, and then they adjust the parameters or whatever to account for the missing stuff. But they're not actually modeling the entire universe. So this metric that I'm saying, this is the entire universe. So it's the perspective is the RS. So that's what you have to compare to. You have outside of RS, and when I say RS, I'm talking about the Schwarzschild radius. Schwarzschild's a rough word. It's even harder to write, and I've written that word a million times, and I always forget the Z. Anyways, I don't know why. I forget that first H too quite a bit. Anyways, what was that? Now I'm confused. I'm so sorry. Hold on. Okay, so for the in modern cosmology, the FLRW is lambda cosmology. That's the mainstream metric. That's what they use. That's what everybody agrees upon is the metric that defines the universe. This perspective has to have this flatness also. But where does it come from in the Friedman metric? Nowhere. Imagination. The flatness just exists as a concept. The flat universe, you have to have a flat space-time of which to compare it to. The Friedman metric just exists, not as a realistic thing, but as a conceptual thing to compare it to. To me, that's the problem. In the universe, in the metric that I'm proposing, outside of RS, you can see it in the equations. 0. And so you have something to start. You have a way, because it's not truly 0 as you move closer to it. It manifests in, in other words, as you move, the RS move, the radius, the Schwarzschild radius moves with you. So any observer has this observable limit. And it's created by gravity. This observable limit is created by gravity. And so it's a real but false boundary, which provides a frame of reference for you to compare. You can start. And the way that I've done it, we'll get into that in just a second. Maybe, I don't know. So it agreed with me on this one. Your perspective highlights a philosophical refinement of general relativity, the idea that metrics are not imposed by global considerations but are emergent from the observer's frame. It suggests that the Schwarzschild metric should not be seen as the fixed global structure with an arbitrary division. Yeah, this is Whitehead. This is Alfred North Whitehead's proposals, basically. Is you can't think of the universe like as objects as existing outside of other objects. It's only one object, okay? And that's this continuous manifold that is general relativity. Everyone forgets of this. It's a continuous manifold. But modeling it as a continuous manifold is tricky. So I asked it to formulate this metric finally after talking to it for a while. And where does it get? Oh, here we are with the K. So it's using a new constant. It just created this constant to keep the mass density distribution inversely proportional to R. And so I don't really want, that's not really the metric. The metric isn't really that the mass density is inversely proportional to R. It's acting like that's a rule. Oh my God. I said ass. That's hilarious. My keyboard sucks. I need it. It's so old I can't see the keys. It lights up, but the letters are all rubbed off. And the keys don't click the way they used to. You have to press them a lot harder. So it just drew the Schwarzschild metric. Yeah. Anyways, this is my workflow. Like, so this is what I do. And so if I get a good equation, I'll save it. If I get something good, and I can bounce it. Like, sometimes I'll bounce something through Claude. I'll tell you something else that Claude is really good at is creating visualizations. You can just create all kinds of stuff with oh. And this is very helpful. I love using Claude. Oh, Compastic, unable to respond to your message. Why? See, come on, man. It always does this when you're trying to do something. It fails. The demo is possessed. We need to banish it. Anyways, what is going on with this? Space-time dot. See, you can, you can tweak it, whatever. It pretty much always uses, I bet this is, what is this? I don't know what this is. Anyways, I love using Claude for stuff like this. You can also use Claude the same way you use ChatGPT. But see, I made my own calculator, and that's another thing I'll do with Claude is just make my own calculator. Sometimes you just want your own calculator. What else we got? Google is another huge one, dude. Google Calculator has been so solid for just quick stuff because you can just type, like you can just mix things, and like you can use C and it just does, and it actually does 299,792,458 meters per second. It doesn't round to 300. I have to constantly correct ChatGPT and Claude on that. They round to C. Everybody round. Like there's all kinds of calculators online that you round to C to 300 meters. And I'm like, why are you rounding? This is a calculator. Like it's literally the most precise thing ever if you don't round. It's so stupid. Anyways, and then Wolfram, just using the Wolfram directly is great because you can get very precise. It's a good calculator. Like it doesn't round, I don't think. I mean, sometimes it probably does. What else do I use? I don't know. Oh, spreadsheets. Yes. So you can just type sheets.new and Google will open a spreadsheet for you. And I love using spreadsheets. Spreadsheets are great because it's what I'll do. I'll just start off. I'll go here and just type. Like this is the gravitational constant. And then here we'll do the observable radius. Then here we'll do the speed of light. And then here we'll do, this is just an example. And then you have to change to scientific on this one. Oh, it is. Or it'll go around. And then we can do, so equals divided by 0.0868. Fat fingers. So this is the number of megaparsecs. Let me just distance from observer. Megaparsecs. This is in meters. Distance from observer in meters. Megaparsecs, speed of light. See, this spreadsheet rounds, but that's fine. But I still would rather just see 2.99. That way I know it's speed of light instantly. I don't know what 3.00 means. I really don't. That means nothing to me. This is gravitational acceleration. And then G, we have gravitational constant. Ooh, I am all over the place. The Hubble constant. And so to make the Hubble constant, we'll do equals I think that'll be right. No. We'll just do that for now. And then, whoa, why is it doing that? 2G. Well, I don't want to start doing it because it's hard to think about broadcasting and whatnot. I should be able to do that though. You guys are probably bored to death. Nobody's listening to this at this point. No one made it this far. If you did, why? That ain't gonna work. I need to do that because speed of light's in this. And then, see, this is escape velocity. It's not Hubble constant divided by the number of megaparsecs. Yeah. And then so we can do, the reason I like the spreadsheets is because you can get more precise answers. You can't keep up with units, which sucks. It really does suck. But so long as you just keep up with it in your head, that's all you got to do. And you can check Google. You can use it to Google to check your equations to make sure your constants or Wolfram or whatever, to make sure that your dimensions and units are all consistent. But I like it because you can see how everything evolves, and you don't even have to make anything. So it's telling you, see, this is 72,000. Well, go away. 72,000 meters per second per megaparsec. Okay, and so that's telling you that that's the Hubble constant. So it's, and then I guess this is the escape velocity. Anyways, and you can just see whatever you want. Like you can do this. Well, whatever. There we go. I don't know. I forget how to do tables. I don't want to do that. I guess we're done here. I just want to keep talking. I don't know. I have other stuff that I use, but these are the things that I use non-stop. Like, it's just so helpful. And the reason is because, like, here you can see the escape velocity, but you can see that the Hubble constant changes. And so now we could apply another variable to this times 0.12, whatever. And then you can see how that changes. And then we can do the mass over here. You can just do another equation. Equals oh, I messed up. I divided. I don't have to do that. I can just do. See, this is why it's nice. Like, if you have brain farts, you can just come over here, and then you can do. You have to use. Make sure you use different variables. So I just had a brain fart about how to solve for mass. And so you can just go bam, Oh, FR squared. Yeah, now I know what I was. See, I put just F times divided by G. And so that'll give us the total mass. And then you can see how the mass evolves. You can see this is so amazing. And this is very basic. This is all basic shit. But it's great for capturing the essence of how the equations change. And a lot of people do this with curves. You can create the chart if you want. And that's another thing that ChatGPT will do. You can be like I'm trying to think. It'll get this. And see, that's amazing. You can be, plot. I should have said plot. Sorry, I don't know what to say when it's doing stuff. When I'm waiting, it's just like my brain stops, but I should keep talking. So this shows you the relationship of mass density to the radius in a chart. And so, I mean, I'll have a spreadsheet open like this, but still use ChatGPT because these are so much better than what spreadsheets make. Like, that is beautiful. And I can't use Python. I mean, I can for small things, but I'll have to get ChatGPT to help me walk me through it, like to do something like this. Like, it's just, but ChatGPT will do it instantly. Look how quickly I got that. I mean, and yeah, you have to pay attention. You have to pay attention. They will screw you. It will give you a chart that's wrong. It will, absolutely. When it does that, you give it a thumbs down. When it does good, you give it a thumbs up, and it's that simple. I love it. I mean, it's well worth. I pay for that and Claude. And I even do some some of the API stuff. But I mean, all that, it's fun. I love the AI, but I am nervous about AI. Don't get me wrong. I feel bad that I'm contributing to the downfall. But my doom, like there's this, what is it? They call it P doom. My P doom is high for humanity and civilization. But it has went down, okay? And I have a large margin of error for ignorance there because, that's what we do as humans is kind of look for doom. That we kind of are always looking for reasons for doom. And it's, AI definitely makes me really nervous. I think it's a dangerous tool. But there's also the potential for amazing things. If we can make it to other planets and create ecosystems of living organisms on those planets that were, like, if we can go to like Mars, if you come back in, say, 3,000 years, if there's just forests on Mars, that'll be amazing. It'll be worth making AI, so long as we don't die in the process. But there's ways of avoiding it. I don't know if they're gonna do it though. I honestly don't trust the folks in Silicon Valley. They're not very good. They're good at doing stuff and making money and being assholes. Anyways, I've probably said too much at this point. Thanks for listening. If you made it this far, you didn't though. Anyways, good night.